Okay, so this comes from exam prep 12. It's question number 4D. And we've got to write an expression that includes P and the inverse. So I've got to have P and I've got to have the inverse of H as part of the answer, which gives the average value. So average value of H of X over that interval. So we know the rule is P minus 0, integral from 0 to P of H of X dx, when P minus 0 is P. Now the problem about that is that I'm using H of X, not its inverse. Okay, so if I was to think about what area do I actually have, this integral represents that area there. And that area there is the integral of H of X, and this is H of X going from here, continuing on and continuing down here. And we've previously worked out that that y-intercept is through 2 log by c of 3, which means on the inverse, that point there is 2 log by c of 3. And we are doing it from P. So that point there is P, which means the x-coordinate there is P. And where the function crosses its inverse, it will also have the same y-coordinate, which is P. So that there is P. So this represents that yellow area. And I'd like to replace that yellow area with an expression to do with the inverse. So if I was to consider the inverse graph is this one here that continues along here and goes to there. And at that point there is P. And that if I was to do the dotted line across, this area here represents all of this yellow area here. So if I was to put a straight line down, here, this is this here, which is P times P, that's P squared, because it's a square. We've got P squared. So what I'd like to do instead is to write this as being instead P squared, which is this, plus the integral from P, so from here to 2 log by c of 3 of H inverse of X dx, and that's going to represent the same as that yellow region. And since I'm dividing all of that by P, it's going to equal P plus 1 on P, integral from P to 2 log by c of 3 of the inverse of H dx. And that's the area that represents, that's the value that represents the average value of H of X.